Hi, I'm Alex Nauda, CTO at Noble9, and I'd like to share with you some techniques I found to help control the population of my runaway test and production environments in our cloud-native world. Let's go back maybe 10 years. I was running applications in a traditional data center or a colo, and you've heard this, right? We treated our infrastructure as pets. They were high maintenance, long-lived, really precious to us, and we gave them names. A few years later, I migrated into the public cloud, and I started treating my infrastructure as cattle. It was lower maintenance, shorter lived, disposable, and we would tag them. Nowadays, in Kubernetes, the experience is a little different. Our environments are unmaintainable, they're temporary. Sometimes I consider them to be pests. They can be forgotten as soon as they're stood up. I think rabbits is the proper metaphor for this. How many test environments do you really need? How many production level environments do you really need? Too many. Let's talk about how many environments we used to have. Per application, back in the day, we usually had about one production environment, max of 2 or 3 if it was a high availability application. We'd have maybe 3 test environments: integration test, QA, staging. That's about it. Then you go straight to prod from there. In the cloud years, we had 2 to 3 production environments: active, passive, sometimes a warm location, a cold standby. And in this era, it got easier to create test environments, and we'd create maybe 6 to 9 test environments per application. Each team had their own stack of test environments. We created separate environments for CI. We created separate environments sometimes for a long-running branch. It got to be a little bit messy. Nowadays, I'm counting sometimes upwards of 10 production environments, especially when you get into multi-region and multi-cloud deployments. Countless test environments that are dynamically stood up and dynamically torn down. They're multiplying. What can we do about it? Let's talk about how many prod environments we actually need. In a regional high availability, as I mentioned, you're probably going to have one for every supported region. Maybe you double that to go to a second supported cloud if you're looking for a multi-cloud deployment, whether that's required by your application or you're doing it for reliability. Then you have your DR. Sometimes that involves a passive environment, warm environment, cold environment. And now we have blue-green. What is your green environment doing when your blue one is actually wired up to your load balancer? How do you tear it back down and create it again, which is one problem, or do you keep it around, which is a different kind of similar problem? I'd also like to point out that some of these environments, a region where it's currently nighttime or a low traffic time period for the people who would use that region, your warm or cold DR environments and whatever additional production environments you're not using, they often have no traffic at all or very sparse traffic for much of the day or much of the time that they exist. Now let's talk about test environments. Typically, you're going to have a shared hosted development environment, probably per team. In addition, though, nowadays it's so easy to create and tear down environments. Individual developers want their own hosted environments. It's a lot more like production when you can put it in the cloud next to your production environment. I understand that for backend devs, but nowadays everybody wants one, and it's certainly more convenient. We have CI environments. We create a new CI environment for every single pull request if we want. At least one QA environment. In my last shop, we had 3 going on 4. A staging environment. A UX validation, so our designer, our product team can get in there and look at stuff early on in the development process. We have a sales demo environment. Technically, that's probably production. Separate pen testing environments, sometimes multiples in parallel if you have both customers and internal testers going after them at the same time. It really is getting to be too much. Again, there's often no traffic in a significant number of these environments. And in addition, it's not always clear who responds to alerts for these, who's really monitoring them. So let's talk about that. Here's a problem statement. All of these environments, the sheer number of them makes them unmanageable. They're already expensive. They're overstimulating. And they're pretty diverse. There's a variety of use cases and traffic patterns. We have differing requirements for reliability across these stacks. We need appropriate SLOs to monitor these environments. I think you all know what SLOs are and how they work at this point. Here's a screenshot from Noble 9. I think you understand what SLOs are. I'd like to talk more about the nuances of using those for these types of environments that have less traffic or not directly typical users going against them at any one time. There's two properties of SLOs I'd like to keep. One is SLOs can be very low context, a lot less like an airplane dashboard, a lot more like a check engine light. And that can be a really good thing. It's a set and forget situation. I can look for the alert and respond to it when it comes up. Second property, they're easy to operate. This is a small soundboard and it already has too many knobs on it. If I'm creating something for test environments or for an environment that's not readily going to be used on a regular basis, I want simplicity. I want a single knob, maximum of 2. So I can sort of say, turn that thing down, it's too noisy. Turn it up, I don't want to miss that alert next time. Next, and this is a prerequisite, your SLOs have to be automatable. So already your infrastructure as code or GitOps system is creating infrastructure from your CI/CD system out of your repos. It's standing up your applications. If this is going to work in parallel with that, we need the same thing. We basically need SLOs as code, or it's not really going to be feasible to treat the actual symptom. The challenge becomes, what do we pick for the SLIs? Traditional SLIs depend a lot on user activity. We recommend our customers use key business metrics. In fact, we run workshops with them to identify key business metrics. We try to tie them to user satisfaction as much as possible. Who even are the users of a test environment or your DR cold site when it's not being used? What can we do instead of your typical SLI selection or simply copying the ones from prod and trying to downgrade them in some way? First of all, we can use what we call occurrences-based SLOs. I'll talk a little bit more about those in a moment. Second, we can monitor for lights-on behavior. If you're going to generate a set of baseline SLOs for all the way down to a development environment, you want to monitor for lights-on behavior because that's the first way it's going to break. And finally, we can use synthetics. And we can use synthetics that monitor across pretty much our entire stack, including all the way down to the infrastructure, all the way up to the application, all the way out to whatever the user is of each environment, even if it's a test or development environment. Let me talk about occurrences-based SLOs that I mentioned. These are also known as event-based SLOs, and the way they work is they measure a straight ratio of successful events. For example, how many requests succeeded, or how many jobs or attempts succeeded or succeeded within certain boundaries, whether it's time or quality or something else. And this is opposed to a time slices approach that would measure good minutes versus bad minutes. So these SLOs automatically adjust for low traffic periods. Consider this. Let's say you have a road closure, whether it's because of a construction or accident. If you do that during rush hour, you're impacting a ton of drivers. If you do that in the middle of the night, you may impact a few drivers, but way fewer. So if you were to use open minutes versus closed minutes for your road, you'd be penalizing that SLO equally, whether it's during rush hour or in the middle of the night. If you instead count how many cars attempted to go through the road, it will self-correct for times of low traffic. And I'm going to recommend occurrences-based SLOs for a bunch of these things. Next, let's talk about lights-on monitoring. So lights-on monitoring for infrastructure and clusters is definitely doable. If you're in Kubernetes, you have kube state metrics. You can come up with some basic stuff. This is just the most basic stuff out of the gate. Are my nodes on? Here's example promql. Are my pods on? Let's just check whether my deployments are actually running, whether my daemon sets are actually running. Okay. Can I tell if my Kubernetes is in fact working, that it's not broken. And I'm going to go back to like the earliest literature on this from Kubernetes, which is, let's look at the Kubernetes API response time. Let's use an occurrences method of SLO, because all night long, if there's a single failure, I don't want it to look like it should count that much against my SLO. And let's look at pod start latency. Again, occurrences method SLO. Anytime something gets restarted, I can see how long that takes as well. And let's talk about the same thing for applications. So there are hosting specific ways you can do this. For example, if you're using certain type of ingress or load balancing, one prototypical example of this might be, say I'm using an AWS ALB. I can look for an unhealthy count. Any unhealthy count on my ALB probably tells me that there could be a problem there. Latency of requests and events. Again, an occurrences method SLO could work with a latency metric. I may have to dial down the expected latency if I'm undersizing my infrastructure, but it's certainly doable. Same thing with success rate with an occurrences method of SLO. You have to be careful, because in a lower level test environment or development environment, you could very well have failed requests because a developer has, a partially broken deploy. They're not working on that part right now. So like I said, you need an easy way to dial them down to make them appropriate to that level of environment. But if you're using an occurrences-based SLO, it'll already account for the lack of traffic, and you're basically just tuning the performance that you want to see. Next, let's talk about synthetics. So in infrastructure and in clusters, I really want to tip my hat to Kubernetes. Kubernetes is a synthetics framework that does a wide variety of things, but the three that I think are most applicable to pretty much every single environment are checking DNS resolution, deployments, and daemon sets. So basically, Kubernetes is going to try to resolve a DNS name. It's going to try to do a deployment and then tear it down, try to create a daemon set and tear it down, and it will track whether those are successful. So at least you can know via these synthetics, even if no one's using the environment, you can know that it is in fact up and running. The cluster is in fact usable for what the developers might want to do with it. Next, we come to applications. So let's talk about some synthetics for applications. You need to have automated functional tests to do this. If you have automated functional tests, great. If you are lacking coverage in some part of your stack for automated tests, or if you're not able to run them in your environment, you might consider some of these popular tools. Mabel, it's a great functional testing cloud system that could be applied to anything internet facing, maybe I think also stuff that isn't internet facing. RunScope, which is kind of an API synthetics. It can run your REST request as a synthetic. And Ghost Inspector, which is a front-end testing tool that offers some visual inspection. These are RunScope and Ghost Inspector are both pretty simple tools, but they work really well to get up and running quickly if you're looking for some additional coverage to make sort of a smoke test kind of framework for this kind of thing. I would run them regularly in every single environment. In production, run them on an isolated account or tenant. So let's say you have a DR system, or even it could be a region that gets very little traffic at night, but where you need to run a deploy because you're running a deploy right now. Your user-facing SLOs may not actually give you a good read on whether you've broken something. Run your tests everywhere. In test environments, all the way down to a development environment, it might seem a strange place to run a test harness. Typically, those are kept to CI, but if you do it, you know that that environment is also working correctly. Again, you might need to dial it down. So one good way to do an example SLO for this would be to do total tests succeeding over total tests run over a 1 hour period, for example, for an alert if it's during the day. It doesn't matter how many times you run the thing. You're not really trying to achieve a high degree of success in a low-level development environment, but consider that even if your target was I want my tests to succeed at 60%, let's say. If that drops to 20% or to 0, you know you have a problem, even if much of the environment was broken before. You can use a very strict target for these in production. If you're not running your functional tests in production on a regular basis, even in an isolated account, you should be. And then, like I said, you use a lower target for development environments. Next, let's define clear ownership for the non-production SLOs. I mentioned sometimes it's hard to tell who owns what. It's really important that developers have autonomy to support their own workflow, so I like to encourage that. They should own their own individual hosted environments. I don't want the infrastructure team or even the application owner getting an alert for an individual hosted environment. So that's an easy answer, is to make that owned by the individual developers. For shared environments, like an integration test environment, QA, etc., one of the patterns I've seen work, if you aren't big enough, I work at a small company, we don't have a separate team to maintain these things. If you're looking for a way to do it that's potentially a repeatable pattern, consider assigning a rotating role, sort of a mechanic. Maybe it's sprint by sprint. If you have multiple areas on the globe, even at a small company, you could do round-the-clock rotation on this as well, follow the sun sort of thing. And then finally, business-critical environments. Business-critical environments need some special care because, let's say I have a sales demo environment. That is essentially a production environment to my company. I need to treat it as a production environment. I would consider making the ownership of that and the reliability of that close to, if not equivalent to, a production system. Potentially lower criticality during non-working hours. So you do need features in your SLO reporting or in some other aspect of your system to account for the fact that I don't want to wake anybody up for a sales demo if I know that nobody's using that environment right now. So to sum up, how to do rabbit control. First prerequisite, you need automatable SLOs as code. Next, create a set of simple SLOs that work in any environment that you can generate. Set and forget them until they alert. You need to work around some issues caused by sparse traffic. So, as I mentioned, monitor lights on behaviors instead of something that's truly user-facing. Make the most of synthetics so that you can give the system some traffic that has a reasonable expectation of reliability. And then finally, define clear alert policies and ownership for those generated SLOs. Thank you very much. My name's Alex Nauda. You can find me on the SREcon Slack. Also, I'm Alex Nauda on Twitter. Here's my email address. Drop me a line. I'd love to hear from you.